Hello friends, welcome to the session. Continuation of chapter 2 error analysis. Yes, in the last session I discussed about how to do the error analysis in combination of quantities. Okay, that is the second concept I discussed. How to do error analysis in addition, subtraction, multiplication, division, composite factor. Okay, all this I discussed. Okay, now in this session we'll continue with what are the types of errors mainly in measurement system. That is also types of static errors. That concept is also with respect to types of static errors. Means these errors may occur in the measurement process. These errors may occur in the instrument due to instrument also. That's the reason why these are the types of static error or types of errors you know down. This totally theory concept. Already questions are framed based on this concept also. Okay, then put the heading types of errors or types of static errors. Okay, in this I am discussing the types of errors. In general, the errors are broadly classified into three types. One is gross errors. Gross errors. And another one is systematic errors. Yes, concentrate all of you. Systematic errors. Third one is random errors. Random errors. Okay, these are the different types of static errors. One is gross errors, systematic errors, and random errors. Now we concentrate what exactly gross errors. What do you mean by gross errors? You tell me. What is the reason for gross errors? Yes. These are the errors due to human mistakes. That means gross errors are mainly due to, these are the errors due to human mistakes. Human mistakes. These are the main reason for gross errors. Then which are the human mistakes? Yes, so many errors which causes due to human mistakes is, here I want to give some examples. One of the example is carelessness in noting the readings, recording the readings, and calculating the results. That comes under gross error. Carelessness in noting and recording the readings. Yes, note down this. Yes, carelessness in noting and recording the readings. Recording the readings. Yes. And calculating the results. Calculating the results. This comes under gross error. The another example is inexperienced user or wrong selection of meter range. What do you mean by inexperienced user or wrong selection of meter range? Means to measure 40 volts, we are connecting 600 volts voltmeter. That is meaningless. For measurement of 40 volts, which is the best selection? 50 volts voltmeter is best selection. To measure the 1 ampere current, we are connecting 10 ampere ammeter. That is also meaningless. That is due to that, which error will be increases? Limiting error will be increases. That's why wrong selection, inexperienced user or wrong selection of meter range. Inexperienced user. Yes, inexperienced user or wrong selection of meter range. Wrong selection of meter range. Meter range. Next, one more example is error due to loose connections. Error due to loose connections. Loose connections. This also comes under gross error. Error due to loose connections. Okay, these are the different reasons for why the gross errors. Carelessness in noting, recording the readings and calculating the results, inexperienced user or wrong selection of meter range, error due to loose connections, or error due to incorrect adjustments also. All these comes under gross errors. Then how to reduce these gross errors? Yes, we don't have any in detail mathematical analysis in order to reduce these gross errors. No doubt at all, these gross errors cannot be eliminated completely, but you can reduce. Only two methods mainly you follow. One method is to reduce the gross errors, take the readings more carefully. Take the readings more carefully. Record the readings more carefully. That is only one way to reduce gross errors. The another way of reducing the gross errors is, instead of taking one reading in a particular experiment, we are measuring particular voltage. That same voltage we can measure. Instead of one time, you can measure 10 times. Whatever the values we can get, take the average value of that. Then we can reduce the gross errors. That's why gross errors are reduced only mainly two methods: by taking the readings carefully and taking set of readings by average of that readings. Then we can reduce the gross errors. Understood? Okay, these points you remember with respect to gross errors. Clear? Then another one is systematic errors. Systematic errors. Systematic errors. Yes, why the name is given as a systematic? These errors are common for every user. That's why these are nothing but a systematic error. These errors are, yes, these errors are common for every user. Common for every user. That's the reason why name is given as a systematic. But this will not depend on the user, but it will depend on the user. Yes or no? Who takes the readings more carefully, the gross errors will be reduced. Who takes the readings with carelessness, the gross errors will be. That depends on the user. But here, these errors are common for every user. The reason I will tell. That's why name is given as a systematic. Okay. Then the systematic errors are again three types. One is instrumental errors. Yes, instrumental errors. Another one is environmental errors. Environmental errors. Environmental errors. Another one is observational errors. Observational errors. These are the different types of systematic errors. Instrumental errors, environmental errors and observational errors. Tell me, what is the instrumental errors? Instrumental errors. Yes. What do you mean by instrumental errors means? These are the errors due to structure of the instrument. Based on the structure of instrument we are using, we can get some error, that is nothing but instrumental errors. Or these are the errors due to low quality or substandard materials used in the instrument. Low quality or substandard materials used in the instrument. That is, these are the errors due to structure of instrument or low quality materials or substandard materials. Yes, low quality materials used in the instruments. This is one reason for instrumental errors. Then what are the different types of instrumental errors? So many types of instrumental errors are there. And these errors may be occur due to inherent shortcomings. It may occur. And error due to aging effect also comes under instrumental error. Error due to aging effect is also comes under instrumental error. Error due to irregular spring tension. If always the spring tension is changing within the meter reading is also changes. That is also comes under instrumental error. Yes. Loading error, that is due to loading effect. In detail about loading effect, that later on I will discuss. Okay. Then whatever the error specified along with instrument, that means whatever the error specified by the manufacturer along with instrument, that error is with respect to instrument only. That error is due to instrument only. What are the errors specified by the manufacturer? Yes, percentage limiting error given by the manufacturer along with instrument, that is also instrumental error. Percentage guarantee accuracy error is also given by the manufacturer along with instrument, that's why it is also instrumental error. Then what are the examples of instrumental error? The examples of instrumental error is, one is percentage limiting error, yes, percentage guarantee accuracy error. These errors are specified by the manufacturer along with instrument based on the design consideration. Yes, a manufacturer will specify like this: a 0 to 150 volts voltmeter having accuracy of plus or minus 2% of full scale reading. That means if you use this instrument in the measurement of 150 volts, we can get plus or minus 2% error. That is, this is specified along with instrument. That's why guarantee accuracy error is also instrumental error. Limiting error is also instrumental error. One more example, error due to aging effect. Yes, error due to aging effect is also comes under instrumental error. Error due to aging effect. Okay. Third one is loading error. Loading error is also, it is due to loading effect. That loading effect will cause us the instruments only. In detail about that later on you will see. Loading error is also instrumental error. Loading error is also instrumental error. Okay. Then one more example, error due to irregular spring tension. Error due to irregular spring tension. Irregular spring tension is also instrumental error. One more example is error due to inherent shortcomings. This is mainly due to inherent shortcomings. Inherent shortcomings is also comes under instrumental error. Sixth one is misuse of instrument. Misuse of instrument is also comes under instrumental error. Okay, the instrumental errors are mainly due to mainly due to low quality materials used in the instrument or structure of the instrument. These are the different examples of instrumental errors. Limiting error, error due to aging effect, limiting error, guarantee accuracy error, error due to aging effect, loading error, error due to irregular spring tension, error due to inherent shortcomings, misuse of instrument, all these comes under instrumental error. Clear? Understand? Concentrate. Quick. This concept is totally theory. Based on this also, some gate questions are there. Quick note down. Why these instrumental errors are called systematic errors? For example, I am using one experiment. So I am doing one experiment using one instrument. Because of that instrument, I am getting 2% error. Same instrument you are also using. Due to that instrument, you also get 2% error only, na? Yes or no? That's why it will not depend person to person. Always for all the users, it gives the same error. That's the reason why name is given as systematic. But this instrument cannot give different errors for different users, na? I am using that instrument, I will get 2% error because of I am the faculty. You are the student, you get 3% error. Is it possible? No. For all the users, it gives the same error. Na? That's the reason why the name is given as a systematic. Instrumental error is a systematic. For all the users, it is constant. Understood? Next. What are the environmental errors? What is the environmental errors? In systematic errors, the second one is environmental errors. Yes, note down. Environmental errors. Yes, the reason for environmental errors is, these are the errors due to change of temperature, humidity, barometric pressure, dust and vibrations. All these are the reason for environmental errors, or these are the reason for environmental errors. Understood? That is, the reason for environmental errors is due to change of temperature, humidity, barometric pressure, dust, vibrations, and external electrostatic and electromagnetic fields. Electrostatic and electromagnetic fields. This is the reason for environmental errors. Okay. Then the examples of environmental errors is temperature error is one example. Stray magnetic field error is another example. These are the examples of environmental errors. But how we can reduce this environmental error? How to compensate or how to reduce this environmental errors? One method is, we can use that instrument under controlled condition. For example, we are using particular instrument in a particular condition. If temperature is heavily increasing, if temperature is reducing, then we can use that particular instrument in controlled conditions. There may be temperature controlled condition, there may be humidity controlled condition. Like that, in the controlled condition, we can use that instrument. Like that, we can reduce the environmental errors. The another way to reduce environmental errors is, we can provide proper shielding arrangement. We can use that instrument under shielding arrangement. Then we can reduce the, that means these environmental errors are reduced. These are reduced by using instrument reduced. One is by using instrument under controlled condition. Controlled conditions. That is one way to reduce environmental errors. The another method is by providing proper shielding arrangement. Yes, by providing proper shielding arrangements. Shielding arrangements. Shielding arrangements. By providing proper shielding arrangements also, we can use this, we can reduce this environmental errors. Clear? That you consent. This also common for every user. Yes or no? In a particular condition, we are doing one experiment. At the same conditions, when I use that instrument at a particular condition, whatever the environmental effect is there for me, if you do the same experiment, for you also same environmental effect, it will not changes from, suddenly it will not changes from person to person. That's the reason why these errors are taken as a systematic errors. Then third one is observational errors. Observational errors. Tell me, what is the reason for observational errors? The reason for observational errors is, these are the errors due to improper methodology incorporated in the instrument. That is, this is error due to, these are the errors due to, yes, improper methodology incorporated in the instruments. Methodology incorporated in the instrument. This is a reason for this is a reason for observational errors. Improper methodology incorporated in the instrument. What is the improper methodology? We know that these observational errors mainly occur in the analog instrument. These errors are mainly in analog instrument only. We don't have any observational errors in the case of digital instrument. Yes, in any analog instruments means there is a scale and pointer movement. There is a scale and pointer movement. That is, pointer is moving on the scale. But during design, for the free movement of the pointer on the scale, this pointer is not attached to the scale. During design, the pointer is not attached to the scale. For example, I am measuring 5 volts. If this pointer is exactly attached to the pointer, if this pointer is exactly attached to the scale, then we can exactly measure 5 volts. Yes or no? But it is not completely attached to the scale. Why? Yes, if it is completely attached to the scale, because of friction effect, this pointer will not move free. This pointer will not move freely. Yes or no? That's the reason why for free movement of the pointer, then some bending is provided on the pointer. We can make some bending like this. Whenever some bending is provided on the pointer and scale is not on the same plane. Once the pointer on the scale is not on the same plane, even though we can measure more accurately, but we can get some error. That error is nothing but observational errors. That's why these are the errors due to improper methodology incorporated in the instrument. What is improper methodology here? This pointer is not exactly attached to the scale. For the free movement of this pointer, we are making some bending. Whenever we can make this some bending like this, pointer will be bended like this. Then the scale and pointer is not at the same plane. Compulsory, even though we can take more carefully, compulsory we can get some minimum error. That is nothing but observational error. The example of that observational error is nothing but a parallax error. Understood? That's why due to improper methodology incorporated in the instrument, we are getting error. This is nothing but observational error. Then how we can reduce this observational errors? That means in order to reduce the observational errors, we must maintain the scale and pointer in the same plane. Or otherwise, you see in most of the whatever the instruments we are using in our laboratory, okay, then most of the instruments are designed with, most of the instruments are implemented with some mirror arrangement. What the purpose of using mirror means, whatever the error we are getting because of bending of this pointer, in order to compensate that one, you take the readings in mirror image. Once we can take the readings in mirror image, then we can reduce the parallax error. Understood? That means parallax, the example of observational error is parallax error. Observational error is parallax error. These observational errors are reduced by taking the readings in mirror image. These are reduced. Observational errors are reduced by taking readings in mirror image. By taking the readings in mirror image. By taking the readings in mirror image. Okay, this is what exactly observational errors. I think you know that if three members are conducting an experiment and one person is standing here seeing from this side, another person is seeing from this side, another person is seeing this side. Three persons will not tell the same answer because of this error, parallax error. One person, if any person is seeing from this side like this, in the measurement of 5 volts, he will tell less than 5 volts. If any one person is seeing the readings like this, in the measurement of 5 volts, he will tell greater than 5 volts. It may, the persons who taking the readings exactly in the plane of scale and pointer, exactly like this, then he will tell the nearly equal answer. Understood? Okay, this is the reason for observational error is because of improper methodology. Clear? Understand? Okay, this about what exactly parallel. But these errors are mainly only in the analog instrument or deflecting type instrument only present. But in the case of digital instrument, we don't have any parallax errors. Digital instrument does not have any parallax errors. Clear? Understand? Okay, this about what exactly is systematic error, that is instrumental errors, environmental errors and observational errors. The third classification of instrument is the third classification of errors. The third classification of errors is random errors. Random errors. Random errors. Tell me, what is the reason for random errors? These are also called accidental errors. These are also called accidental errors. Yes, accidental errors. Okay. These errors, the name itself indicates that random errors. For these errors, there is no particular source or there is no particular reason for these errors. We are conducting any one experiment, then automatically you can get some errors. The type of errors are nothing but a random error. There is no particular reason or there is no particular source for these errors. Okay, that's why name is given as a random error. That point you note down. There is no particular reason or particular source for these errors. But point to remember, these are negligible errors. These are negligible errors. Random errors are negligible errors. Yes. These are estimated and reduced by using statistical analysis. Estimated and reduced. Yes. Estimated and reduced. Yes. By using statistical analysis. Statistical analysis. One more point to remember. These errors cannot be eliminated completely. These errors cannot be eliminated completely. Cannot eliminated completely. We don't have what is the reason for these errors, what is the source for these errors completely. But this random errors is also called residual errors. The name is given as a residual errors. These are also called residual errors. And these are represented with these residual errors, these random errors may be either positive or negative. Random errors may be either positive or negative, and it is represented with both magnitude and direction. It may be positive or negative. It may be positive or negative and represented with both magnitude and direction. One more point to remember, these errors cannot be eliminated completely and estimated and reduced by using statistical analysis. These are negligible errors and these are residual errors. Okay, then it may be positive or negative. That's the reason why it will be represented with both magnitude and direction also. This about what exactly random errors. That means the only way to estimate this random errors is by using statistical analysis or by using probability mathematical analysis. By using probability mathematical analysis, we can estimate this random errors. Okay, this about what exactly different types of errors or different types of static errors. Okay, then one is gross errors, another one is systematic errors, third one is random errors. What are the systematic errors? That is instrumental errors, environmental errors and observational errors. Then what is the reason for observational, environmental, instrumental? That I explained in detail. Clear? Understand? Concentrate. Okay, this is one concept in error analysis. Okay, now we go for last concept in the error analysis. That is very important for competitive point of view. So many times questions framed even in GATE exam also. That is a statistical error analysis. How to do the error analysis using statistical mathematical analysis. That is also very important. Clear? Concentrate. Over? Yes. That random errors, one more point also you remember, these errors cannot be eliminated completely. Random errors cannot be eliminated completely because we don't know what is the reason for those errors. Okay, then concentrate statistical error analysis. Statistical error analysis. Yes. To do the statistical error analysis, we can use some mathematical formulas. First, I want to list out what are the mathematical formulas we are using to do the statistical error analysis. Later on, we will see in the classroom workbook how to solve the questions based on this analysis. Okay, numericals are important for GATE point of view. For any other competitive point of view also based on this topic, numericals is important. Okay, see, what are the formulas we can use to do the statistical error analysis? One is, you define mean. Yes, mean. X bar equal to, how to calculate mean? X1 plus X2 plus and so on plus S Xn by n is a mean. Then you define deviation. Yes, deviation. Okay. Then deviation in x1 is d1. You write x1 minus x bar. Deviation in x2 is d2. You write x2 minus x bar. Okay, and so on. How to write deviation in xn is dn equal to xn minus x bar. Then you calculate average deviation or mean of deviation. Average deviation. Then how to calculate average deviation? It is denoted by d bar or it may be capital D. That is absolute value of d1, d2 plus and so on plus dn by n. Why I taken this modulus means otherwise this average deviation will become 0. But here I want to define the average deviation, that's why I taken modulus. If you don't take modulus, we can get 0 value. But mathematically, in order to do the analysis, I want to define this average deviation also. That's the reason why I taken modulus. Okay, next. You write what is the standard deviation? Standard deviation. These formulas you list out to solve any problem. Okay, standard deviation. The standard deviation sigma equal to, you write like this, square root of summation I equal to 1 to n s di square by n minus 1. Di square by n minus 1. Standard deviation sigma equal to summation I equal to 1 to n di square by n minus 1. It's clear? Next, how to write this? If you want to write this formula for n less than or equal to 20 for finite number of readings, n less than or equal to 20. You also write standard deviation like this, summation square root of summation s I equal to 1 to n s di square by n. This formula you can give for n greater than 20. For n less than or equal to 20, this gives the best results. For n greater than 20, this gives the best results. Okay, then this is the standard deviation. These formulas you already know even in the mathematics also, but here I am list out some formulas to do the analysis in statistical. Okay, next, parallelly note down, don't wait. Listen. Next, write down. Once you know the standard deviation, how to calculate variance. You know this, what is the relation between variance and standard deviation? Variance equal to sigma square. Variance V equal to sigma square. Then precision index H. Precision index H. What is the significance of precision index? It indicates the height of the probability curve. The significance is it indicates, yes, it indicates height of the probability curve. Height of the probability curve. That's why the precision index H indicates the height of the probability curve. That means if you draw the probability curve means this about the central value, then the precision index H indicates the height of the probability curve. Yes, let this is for H1 and this is for H2. What it indicates? In this axis you taken deviation. Deviation is nothing but a standard deviation. Here you taken H. Precision index indicates the height of the probability curve. What is the relation between these two? If height is reduces, what is the deviation? Deviation from the central value or true value. This is central value or true value. Then H is proportional to 1 by sigma. If height is increased, if the height is reduces, deviation is increases. Okay. Then if you remove the proportionality, there is a proof also there. I am not giving here, that you will see in your mathematics subject. 1 by H equal to 1 by root 2 into sigma. Then from this, what you can write? The precision index H equal to 0.707 by sigma. This is a relation between standard deviation and precision index. But you have the one doubt. Sir, why precision index indicates height of the probability curve? Yes. The reason is, in drawing a probability curve, that you know, for example, I am measuring 100 volts. I am measuring 100 volts. And I taken different read. I taken that 100 volts is measured by in different number of steps. See, when I draw this probability curve, the number of times that reading repeated different in the measurement of 100 volts, the number of times different values are repeated is taken on y-axis. Number of times it is repeated, and this is value measured is taken in the x-axis. For example, When I am measuring 100 volts, this 100 volts is repeated for 100 times. It is repeated. 100 volts is repeated 100 times. This is 100 volts repeated in 100 times. And in the measurement of 100 volts, I am getting 99 volts also. 99 volts also. This side you take 99, this side you take minus 99. This is repeated for, this 99 volts is repeated for, this 99 volts is repeated for, let us assume that 90 times it is repeated. 90 times. Okay. Then this is repeated for 100 times. 100 volts. I am getting the 98 volts also. This is minus 98, this is plus 98. Let us assume that it is repeated for 70 times. This is repeated 70 times. In the measurement of 100 volts, 98 volts is repeated in 70 times. I am getting 97 volts also. This you take minus 97, this you take plus 97. I am getting 50 times it is repeated. 50 times it is repeated. That means the number of times the reading will be repeated taken on which axis? Y axis. Then by joining this, what you can get? We can get the probability curve, or it is also called histogram. That's why the number of times repeated, reproducibility, consistency is taken on Y axis. What that indicates? Precision. That's why the height of the probability curve indicates the precision index indicates the height of the probability curve, because in drawing a probability curve, the number of times the reading will be repeated is taken on this axis. Clear? This about precision index. Then you write one more formula. Okay, this is to take probable error gamma equal to, derivation is there, but I am giving directly. Probable error gamma equal to is 0.6745 sigma. 0.6745 sigma. Tell me. Next. Probable error gamma 0.67. Mean of probable error. Yes. Mean of probable error. Mean of probable error. Then how to calculate? Gamma m equal to gamma by square root of n minus 1. Gamma by square root of n minus 1. Next. Mean of standard deviation. Yes. Mean of standard deviation. Sigma m equal to, yes, sigma by root n we get. Sigma by root n. Where n is number of readings we are taken. Okay. That is sigma m equal to sigma by root n. Then standard deviation of standard deviation. Standard deviation of standard deviation. Sigma of sigma equal to sigma by root 2n. How to write this one? 1 by root 2 into sigma by root n. What is the sigma m? Sigma by root n, sigma m by root. Sigma m, that is sigma m by root 2. What is the relation between sigma m equal to root 2 into sigma of sigma? This is the mean of standard deviation. Next, you write maximum value of probability function. Yes, maximum value of probability function. How much? Probability function. The maximum value of probability function equal to 0.39 by sigma. 0.39 by sigma. Then what are the maximum error limits in probability curve? This you know even in mathematics also. Maximum error limits equal to, yes, maximum error limits equal to plus or minus 3 sigma. Next, if set of readings are given, if set of readings are given, if set of readings are given, readings are given, then what is range of error? Range of error equal to, how to calculate range of error is equal to, you do like this, x maxima minus x average plus x average minus x minima by 2. Or you are simply also write like this, x maxima minus x minima by 2. Error may be plus or minus. Error may be plus or minus. This is the range of error. If set of readings are given, how to calculate range of error? Okay. Then one more formula you are writing here. That is precision of nth reading. What is the precision of nth reading? Precision of nth reading. How to calculate precision of nth reading? That is 1 minus xn bar by xn bar. This is the precision of nth reading you calculate. Sixth reading precision, seventh reading precision. Like this we can do. Okay. Next. Very important analysis. Error due to combination of quantities. Yes. Error due to combination of quantities. How to calculate error due to combination of quantities in statistical analysis. In normal analysis I already given. How to calculate error due to combination of quantities. Okay. This concept is also applicable for error propagation. It is also called error propagation. Error propagation concept. Error due to combination of quantities, that is also called error propagation. This important concept, based on these 2 marks questions also there in GATE exam. Now, in addition, in subtraction, in multiplication, in division, how to do the combination of quantity analysis in statistical error analysis. First you write resultant standard deviation due to combination of quantities. Due to combination of quantities. How to calculate resultant standard deviation due to combination of quantities? Sigma x equal to square root of, generalized formula I am giving here. Yes, dou x by dou x1 whole square into sigma x1 square plus dou x by dou x2 whole square into sigma x2 square plus and so on. That means it may be addition or subtraction or multiplication or division, we can use same formula only. The sigma x1 is standard deviation in the measurement of x1. Sigma x2 is standard deviation in the measurement of x2. What is the standard deviation in x measurement? That x may be multiplication or division or addition or subtraction, whatever may be, same formula you can apply. This is the formula you can apply to find the error due to resultant standard deviation due to combination of quantities. Then I want to write resultant variance due to combination of quantities. Yes, write down. Resultant variance due to combination of quantities. Variance due to combination of quantities. Due to combination of quantities. How to calculate resultant variance due to combination of quantities? That is Vx equal to. You know the relation between variance and the standard deviation of variance equal to sigma square. Yes, square and root will be cancelled. Then what you can get? Dou x by dou x1 whole square into sigma x1 square is nothing but a variance. That is, this is a sigma square. Sigma square equal to V. This is the variance, standard deviation in x1. Then you can substitute variance in x1. Dou x by dou x2 whole square. How we can apply this formula? During solving of the problems we get some idea. We can get idea. Then up to that you remember this one. Okay, this is the resultant variance due to combination of quantities. You also write uncertainty due to combination of quantities. Uncertainty due to combination of quantities. How to calculate uncertainty due to combination of quantities? Then uncertainty in x equal to wx square root of dou x by dou x1 whole square into wx1 square plus dou x by dou x2 whole square into wx2 plus and so on you write. This is variance due to combination of, uncertainty due to combination of quantities, wx2 square. See, the standard deviation due to combination of quantities, the variance due to combination of quantities, similar formula, but the notation will be different. Here we are using sigma notation. Okay, here we are using W notation. Formula may be same, but notation will be different. Okay, like this, by using these formulas, we can do the error due to combination of quantities, and this concept is also applicable for error propagation. Clear? Then during solving of the problems, if you solve some problems, then you get idea how you can apply these formulas. But point to remember, here we are doing two types of error analysis. One is normal error analysis, another one is statistical error analysis. In normal error analysis, whatever the errors we have studied, that is nothing but a limiting error, absolute error, all these. Okay. But in statistical error analysis, the errors may be in terms of standard deviation, the errors may be in terms of variance, the errors may be in terms of probable error, like that errors may be represented. In a particular given problem, when you can apply normal error analysis, when you can apply statistical error analysis, then you will solve some problem, then you get idea. Understood? Okay. By given statement of the problem, when you can apply the normal error analysis, when you can apply the statistical error analysis, you can easily identify it. Understood? Okay. This about what exactly the statistical error analysis. In order to do the statistical error analysis, all these formulas we can use. Clear? In the next session, we will continue with the classroom workbook based on this chapter 2. Clear? With respect to error analysis, up to this, the concepts are completed. The first concept is absolute error, limiting error, guarantee accuracy error. The second concept is error due to combination of quantities. The third concept is types of static errors, that is gross errors, systematic errors and random errors. The fourth concept is statistical error analysis. This is the fourth concept, statistical error analysis. Clear? Okay. We will see in the next session, we will continue with the classroom workbook. Thank you.